Okay, so today we have to start waves. So this is the first chapter, which is the basic chapter, and it says that an understanding of color from IGCSE or equivalent is assumed. Understanding of color of white light. Okay, so the first 7.1 is a progressive wave. Progressive waves are actually the waves that can progress through the medium, that can travel through the medium, and then they can transfer energy throughout the medium. So we say that these are the progressive waves. Let's say my sound wave is right now a progressive wave because it is transferring my energy to you. And similarly, the radio waves are also the progressive waves, which are coming from your Wi-Fi router to your mobile phone or laptop, and it is transferring information or signals. So the waves that transfer, that spreads in the medium and that transfers energy throughout the medium are known as progressive waves. So in the progressive wave, we have to look upon their basic features in number 1 and 2. Number 3, we have to look upon the CRO oscilloscope to determine the frequency and amplitude of the waves. And then we have to derive V equals F lambda in 4. Then we have to use it in equations. Then we have to understand that energy is transferred by the progressive wave. And then in the 7th, the most important thing, we have to recall intensity, its equation and its factors. So what is wave motion? Wave motion is simply the transfer of energy. There are like 3 diagrams, 4 diagrams in it. The one with the hand, with the rope, it is known as a pulse. So this is one pulse. This is pulse in rope. And what is pulse? Pulse is actually a non-continuous wave. Like it is a type of wave, but it is non-continuous. It can be either crest or trough. And then if you look on above the water waves, so these water waves are the transverse waves. These are transverse waves because all the particles are moving and there is crest and trough as well. And similarly, this is also the transverse wave. And you can see that the duck is moving up and down and it remains on the same position, but it keep moving up and down. So that shows that wave actually transfers energy. This thing is the longitudinal wave in which a spring is there. You can see that the hand is compressed and then stretched. So you can see that compression and expansions are going on in the spring. So longitudinal wave consists of compression and expansion, and transverse wave consists of crest and trough. So here are the main definitions. A wave is defined as the disturbance caused by the propagation of energy in space or a medium. So this is the valid definition for wave. A wave is defined as disturbance caused by propagation of energy in space or the medium. What are the sources of the waves? Vibrating or oscillating sources. What is its nature? Wave transfer energy without transferring matter. And what is meant by medium? The type of the matter throughout which the wave passes is known as medium. So let's say vacuum or space is a medium for electromagnetic waves. So medium is the thing through which waves are passing. Okay, now we have to look for the wave motion. So what is the wave motion? Wave motion is the motion of waves in a medium that causes transfer of energy throughout the medium. And let's say waves in the rope or water or springs. What are the wave types? There are 2 types of waves. One is the mechanical wave, which needs medium to travel. For example, water, rope, and sound waves are the mechanical waves. Electromagnetic waves are the second type. These don't need any medium to travel. Radio, infrared, light rays are examples of electromagnetic waves. So the mechanical waves are of 2 types, transverse and longitudinal. So what are the transverse waves? You can see in the diagram, this is the transverse wave. A transverse wave is a progressive wave whose oscillations are perpendicular to the direction of wave motion. So this is the main thing. The wave in which oscillations are perpendicular to wave motion are known as transverse waves. So you can see here, the source is this black one. It is moving up and down, and then the wave is moving to your right. So this is transverse wave. You can see in the wave which is moving, C is the wave speed. So the arrows are moving to this way. So it means wave is moving to your right. But you can see that the source is moving up and down, up and down. So the source moves up and down and the wave moves at a right angle to it. So that wave is known as transverse wave. And you have to remember that the particles of medium always follow source. So if source is vibrating up and down, all the particles of the medium would be vibrating up and down. So you can see from this diagram that what is happening exactly here. Okay, now I have paused the diagram and you can see from here that this is the trough. I'm labeling it, and this is the crest, and then this is the trough, and this is the crest. So a transverse wave actually consists of crest and trough. You can see that when the wave is moving to your right, so the particles between trough and crest are moving down, and the particles between crest and trough are moving up. So I am going to highlight them with blue. So between, you can see from here that all the particles that I have labeled with blue, they are between trough, this trough and crest. So they are moving downwards, right? And then the particles between this crest and the trough, next trough, they are moving. As in which direction they are moving? The particles between crest and trough? Upward direction. You can see in the diagram, they're moving upward. So beta, every particle which is between crest and trough, it will be moving upward. And every particle that is between a trough and crest, they will be moving downward. So you can see from the next that the particles between last trough and last crest, they are moving in downward direction. So all the particles of the medium will move up and down. We have to look at in the next case as well. What is crest? The part of the transverse wave that is above the mean line of the medium. So you can see here only crest is being formed. Again, look at it. Only crest is being formed because crest is a part of the wave that is above. So whole this part is what? This is a crest, right? So let's say if I pause it, you can see that this whole part is above the mean line. So we say that this is a crest. So actually this whole part is known as a crest, right? Okay, let's move to next thing, which is trough. So trough is what? It is a part of transverse wave below the mean position. So you can see that this is below the mean position. So only trough is being formed now. So you can see that this whole portion which is below the mean line, this is known as trough. So this is trough. Okay, now let's move to the next wave, which is the longitudinal wave. Longitudinal wave. So what are the longitudinal waves? A longitudinal wave is a progressive wave whose oscillations are parallel to the direction of wave motion. So you can see that the source is moving left, right, like the hand is moving left, right, and the wave is moving parallel to it as well. And particles always follow the source. So above is the top one is the longitudinal wave in the spring, and the bottom one is the longitudinal wave in the sound. You can see the compression and expansions being formed over there. So the region I am labeling yellow, these are actually the compressions, and the regions between them are actually rarefactions. The next thing is part of longitudinal wave, it's compression. Particles of medium are very close to each other in the compression. It is a high pressure region. What is rarefaction and expansion? The particles of the medium are far apart here, and it is actually a low pressure region. The next thing is the terms related to wave motion. The first is progressive wave. So what is a progressive wave? A wave which travels continuously in a medium in the same direction without the change in its amplitude is known as traveling wave or progressive wave. For example, water ripple, sound, light, or any type of wave can be progressive because it has to transfer the energy. Or simply speaking, we can say a progressive wave is the wave that is used to transfer the energy in the medium. Okay, the next thing is displacement. What is displacement? It is the change in the position of medium particles along straight lines after passing from the mean position of the medium. So let's say if when the wave comes, then the particles displace from their position and they go up or down. So that displacement, that is known as displacement. You can see in this diagram over here that how the particles are being displaced. So well, if I stop it over here, so you can see that all these red dots are actually the particles, and they are displaced from their mean line, which is the black line in the middle. Actually, the mean line is this, which I am going to label. So this was the mean line, and all the particles were at this. But when source starts moving up and down, so the particles also start moving up and down. So all the particles are having different displacements. Okay, what is the amplitude? It is noted by ARX naught. So the maximum displacement of the particle from their mean position is known as amplitude. So amplitude is the maximum displacement. So in a wave, all of you knew that the amplitude is actually the vertical height between mean and extreme. So in the diagram on your left, the amplitude is 5 millimeter. But the diagram on your right, as it starts from 0, and this x-axis is distance and y-axis is displacement. So what is the amplitude? The total height of the wave is 20, but you have to divide total height with 2 to get amplitude in this case. So the amplitude in this case is actually 10 millimeter. Like for this, it is 10 millimeter. Because it is starting from 0, but here it is 5 millimeter because the mean line is at the center. Okay, so the next important thing in it is total distance moved by the source is, let's say D. Let's say a source, when it produces waves, so it oscillates. So it goes up, then it comes down to mean, then it goes to another extreme, and then it gets back to mean. So what you have to find the amplitude of the wave if the total distance moved by the source or the particle is given. So you know that the amplitude is the distance from mean to extreme. Like if I label here, this is mean and this is extreme, and this is also extreme. So amplitude is only distance from mean to extreme. So if the whole distance of oscillation is given, what you will do is you will divide that total distance with 4. So amplitude is total distance moved by source or a particle in one oscillation divided by 4. So actually this distance is distance moved in one complete oscillation. Okay, so that is another way to find the amplitude. We will look into a question. You can see from here, there are total 10 vibrations of the source, and the total distance in 10 vibration is 100 centimeter. So this source completes 10 vibration, and it covered 100 centimeter of distance. So what is the amplitude of the wave being produced from this source? So first you will say that 100 centimeter is covered in 10 oscillations. So how much distance is covered in one oscillation? So that is 10. And then you will say that in one oscillation, there are 4 parts. And the length of one part is known as amplitude because it is from mean to extreme. So what you do is you will divide 10 with 4 to get the answer of 2.5. So 2.5 centimeter is the amplitude of this source. The next thing is period. Period is the time required to make one complete wave, time taken by one complete wave to pass through a point, or time taken by a source to complete one vibration, and it is equal to total time over number of waves produced, small t over n, or time is also equal to 1 over frequency, and it is measured in second. That's very simple thing. Again, frequency is the number of waves produced per unit time, that how many waves are being produced every second, or number of waves passing to a point per second. Frequency is 1 over t, its SI unit is hertz or second. So you have to note that frequency of wave depends upon source producing it. Source, so only source can change the frequency of the wave. What is wavelength? It is the distance between two adjacent in-phase points on a wave. Usually we say that wavelength is the distance between two crest or two trough, but that is not the correct definition. The exam definition is the distance between two adjacent in-phase points on a wave. Or we can say that the length between two successive crests or two successive troughs is known as wavelength. Okay, now here is the longitudinal wave, and this is the direction of the travel. You can see that these are the compression, which I am labeling with the yellow. So this is the compression, and the middle between two compression is the expansion. For the transfer wave, it is like this up and down thing, and everything is labeled, like wavelength is labeled. So you can say that the wavelength is from center of compression to center of compression, or it is from top of the crest to top of the next crest. So this is also known as a cycle, and then the trough part, and then the crest part. So these parts are also labeled. This was a simple thing. Now, what is wave speed? Wave speed. Wave speed is the speed that is used to transfer the energy throughout the medium. So we say that as wave travels in the medium to transfer energy, so they have a speed associated with them. Wave speed depends upon medium only. So wave speed depends upon medium, right? It doesn't depend upon source. It depends upon medium. So let's say for sound waves, if sound is traveling in solid, they are faster because molecules of solid are very close to each other. And then in liquid, it's a bit slower, and in gas or air, it is the slowest. So it means speed of sound is proportional to density of the medium. So if a medium is more dense, then speed of sound will be faster over there. For electromagnetic waves like light, they travel faster in vacuum, which is the less denser medium, then a bit slower in air, then both slower in liquid and slowest in solid. So it means that electromagnetic wave speed is inversely proportional to density of the medium. Then the rope waves travel faster if the rope is stretched, like with having high tension. And rope waves travel slower if you stretch them less, or the rope is having less tension. So the speed of waves in the rope depends upon tension in the rope. Next is wave speed expression, which is V equal F lambda. So, you know, when the source completed one oscillation, one complete wave is produced over there. So we say that one vibration is making one complete wave. So the distance that the one wave will travel is equal to lambda, because lambda is the wavelength of one wave. And the time to produce one wave is equal to capital T, which is the time period. So as we know that speed is distance over time, so the distance is lambda and small t is capital T. When you replace it, then 1 over t can be separated, 1 over t into lambda, and you know 1 over t is equal to frequency. So that's how you can prove that this speed is equal to frequency into lambda. The next thing is CRO. This is also taught in chapter 2, which is measurement. So what is CRO? It is a wave plotting device. It is used to measure amplitude, time period, and frequency of a wave. Here in the diagram, there is a simple diagram of the simple sketch of the CRO. So this is known as grid, which I am coloring with blue. So this is grid, and then it has two switches. One is the vertical and one is the time base. So two switches are there, and it plots a waveform on it. So there are two switches. One is the time base or X sensitivity. This switch controls the wavelength of the wave. If you want to stretch the wave or compress the wave, you have to change time base setting or X sensitivity. And then its unit is millisecond per centimeter or millisecond per division. Each box on the CRO grid is known as a division or centimeter. So what is gain? The second switch is gain or Y sensitivity. It controls the amplitude of the wave. Like if you want to increase or decrease the amplitude of wave, you have to change the settings from the Y sensitivity. Its unit is volt per centimeter or millivolt per division. There are three equations that we are going to use. The one is peak voltage. It is equivalent to gain into amplitude of the wave. Gain is actually the Y sensitivity value, which will be given in the question, and amplitude you have to measure, like the amplitude of the waveform. The next thing is time period. Time period is equal to time base into wavelength. Again, time base is X sensitivity, and wavelength is like number of divisions in one complete wave. And frequency is 1 over time period. So you can look here. This is what I was talking about. This is one box. So along x-axis, it is 1 centimeter. Along y-axis, it is 1 centimeter. And you can see that here a wave is plotted on the grid or on the CRO screen. This is the wave plotted. So they have given you that gain is 5 millivolt per centimeter and the time base is 20 millisecond per centimeter. And they ask you to find the amplitude in volts, the time period, and then the frequency. So what you have to do is you have to use the formula. So for the formula, firstly, you have to see that where is the mean line. So this, which I'm labeling with yellow, highlighting with yellow, is the mean line, right? So if you want to find amplitude in volts, it means you have to find the voltage. So voltage is gain into amplitude. So this amplitude is actually the number of boxes, like which is 3, right? 3 boxes is there till the maximum height. So it means, and gain is 5. So you will multiply 5 millivolt per centimeter with 3 centimeter. Oh, sorry, it is 3.5 actually, because a bit more is there. So it is 3.5 centimeters. So the centimeter cancel away, and it will be 17.5 millivolt, sorry. So the amplitude in volts is 17.5 millivolt. Then you have to look for the time base. For the time base, for the time period, it is time base into wavelength. So time base is 20 millisecond per centimeter. And how much is time period? You have to look in one wave. In one wave, how many boxes are there? 1, 2, 3, and 4. So it is 4. So 4 centimeters. So centimeter cancel. 24s are 80. So it means the time period is 80 millisecond. So that's the answer. Okay, and then frequency, frequency is 1 over t. So 1 over 80 into 10 to the power minus 3 will give you the frequency. Okay, now let's move on to a very, very important topic for this first chapter. Wave particle position and the new position of wave in a certain time. Okay, you know that a wave have a certain value of time period and frequency. So time period and frequency is same for source, particles of medium, and wave itself. Like these things, like the time period and frequency, it's exactly same for the source, for the wave, and for the particles of the medium which are moving. Okay, so here in the diagram, again, you can see that all the particles are moving up and down simultaneously. Some are moving up, some are moving down. Between crest and trough, they are moving up. Between trough and crest, they are moving down. And that's how they are forming the wave. So in this topic, what we have to do, we have to tell the position of the particle after a certain amount of time. After a certain time, uski oscillation क्या होगी, इसकी direction of motion क्या होगी. जिस तरह अभी आप यहाँ से देखो, ये सारे जो particles हैं, ये downward move कर रहे हैं, जिसको मैं yellow label कर रहा हूँ. और जिनको मैं blue label कर रहा हूँ, आप देखो वो सारे particles जो हैं, वो upward move कर रहे हैं, right? और उसके बाद जो particle crest या trough पे हैं, वो temporarily rest पर हैं, right? So now what we have to do is कि हमें new wave position बनानी है कि after certain time wave की new position क्या होगी. So let's say a wave is having a time period of 10 millisecond. What does that mean? It means that the source is completing one vibration in 10 millisecond. मतलब source अपनी एक vibration 10 millisecond में complete करेगा और particles are completing one vibration in 10 millisecond. Particles of the medium भी एक oscillation complete करने में 10 millisecond लेंगे. So wave is passing through a point in 10 millisecond. ये भी इसका meaning हो सकता है कि one complete wave like one crest and one trough took 10 millisecond to pass through a point. So that's why we say its time period is 10 millisecond. So you have to draw the new wave position. So let's say this is the previous wave position. These are the particles 1, 2, 3, 4, and then 5, 6, 7, 8, 9, 10, 11, and 12. And its time period is 20 milliseconds. So what you have to do is after a certain time, you have to draw the new wave position. So before we do that, we have to look upon another thing, upon the particle movement. The crest particle, the particle which is at the crest or at the top is temporary at rest. It will move down next moment. Its speed is 0, kinetic energy is 0. The displacement is maximum, so potential energy is maximum at the crest, and acceleration is also maximum. Why these are maximum? Because actually the potential energy is proportional to height. So as height is maximum over here, so that's why potential energy is maximum. And acceleration is proportional to force. So force here at the crest particle will be maximum because then the force will bring the particle back towards the mean position. So the next thing is the trough particles, the trough, which is at the top of the trough. They are again temporary at rest. They will move up next moment. Their speed is zero, their kinetic energy is zero, their displacement maximum, potential energy maximum, and acceleration maximum. So actually crest and trough particles are behaving in the same way. The only difference is crest particle will be moving down next moment and trough particle will be moving up next moment. Okay. Now this is particles between crest and trough. आपने crest का भी देख लिया कि वो highest point पे, trough lowest point पे और ये temporary rest पे. अब let's see कि what will happen to the particles between crest and trough. So you can see here that the particles which are between this crest and this trough, like which I am labeling with yellow, they are moving up. And particles at the mean position, they have maximum speed and maximum kinetic energy, and then they have zero displacement and zero potential energy. So the particle which is at the mean line, passing from the mean line, which I am going to highlight, is actually this one. So these things are written for this particle, which is passing through the mean position or rest position of the medium. So इसकी length of arrow सबसे ज़्यादा है, it shows इसकी speed सबसे ज़्यादा है, इसकी kinetic energy सबसे ज़्यादा है. क्योंकि ये mean line से गुजर रहा है तो इसका displacement zero है, और जब इसका displacement zero है तो इस point पे potential energy भी zero होती है. Okay, the next thing is the particles between trough and crest. Like if the wave is going this way, so जो particle trough और crest के बीच में है वो कैसे behave करेंगे? Okay, hold on. Okay, now you can see here, this is the trough and this is the crest. So all the particles between trough and crest are moving down. So they move down. And particles at the mean have maximum speed again, maximum kinetic energy, zero displacement, and zero potential energy because they are at the mean. Okay, now again, look in this diagram because this is very important. That's why I'm showing you again and again the same diagram. Okay, now you can see from here, this is the summary actually. This is the summary of everything about wave motion we have studied so far. You can see that the particle which is at crest or at the trough or at the crest or at the trough, they are at rest. So crest and trough particles are static. They are at the rest. Okay, then you can see the particle which is moving through mean position, they have maximum length of arrow. It means they have maximum speed. So particles moving through mean position have maximum speed. Then you can see one more thing, the particles between crest and trough all are moving up. Again, I'm labeling them with the yellow. And then the particles between trough and crest, they all are moving down as I'm labeling them with the blue one. So you can see from here, again, just look at the movement of the particles. Okay, you can see here, again, the same thing. This is very important. Particles between crest and trough are moving up, and particles between trough and crest, while the wave is moving to your right, they are moving downwards. Let's move to next. And this is how you can construct a wave with its new position. So let's say the crest has only moved from mean to extreme, and a quarter of the wave is produced. And when the source gets back to mean, like the source completed half oscillation, so half of the wave is produced. So when the source completed 3/4 of the oscillation, then 3/4 of the wave is produced. and when the source has completed one oscillation, so one complete wave has been produced. So that's how a wave is produced and it traveled in the medium. Okay, the next thing is the knowledge about direction of vibration will be used to plot the new position of the wave during its motion. So, well, let me just draw the wave again to give you the example. Okay. Okay. So let's say if you look at this diagram, so this is the position of the wave at a certain time t. ये पहले वाली diagram. And the time period of this wave is 20 millisecond. 20. So what they ask you कि आप 10 millisecond के बाद बताओ इस wave की position क्या होगी. तो what you do is कि जो उसका time period होगा आप उसको हमेशा 4 से divide करेंगे क्योंकि एक oscillation में 4 parts होते हैं. तो आंसर आ गया 5 millisecond. इसका मतलब ये है कि जो हर पार्टिकल होगा ये 5 मिलीसेकंड में एक्सट्रीम से मीन या मीन से एक्सट्रीम पहुंचेगा. अब आप देखें कि ये जो नंबर 2 वाला पार्टिकल है इसने नीचे आना है, ठीक है. तो ये 5 मिलीसेकंड में एक्सट्रीम से मीन पहुंचेगा और फिर अगले 5 में ये नेक्स्ट जगह पे पहुंच जाएगा, राइट. तो इसका मतलब है कि ये पार्टिकल यहाँ पे पहुंच गया, पार्टिकल नंबर 2. अब पार्टिकल नंबर 3 किधर जाएगा, अप या डाउन, या अप जाएगा या डाउन जाएगा. अब आपको ये कैसे पता लगेगा, पार्टिकल 2 पर क्रेस्ट है, पार्टिकल 4 पर ट्रफ है. तो क्रेस्ट और ट्रफ के बीच में जो वेव होती है, जो पार्टिकल्स होते हैं वो अपवर्ड मूव करते हैं, क्रेस्ट और ट्रफ के बीच में अपवर्ड. इसका मतलब है 5 मिलीसेकंड में ये ऊपर जाएगा और फिर 5 में वापस नीचे. तो ये वाला पार्टिकल यहीं पर रहेगा. उसके बाद आगे नंबर 4 को देखें, 5 मिलीसेकंड में ऊपर फिर 5 में ऊपर. इसका मतलब है कि ये न्यू पोजीशन पे यहाँ पहुंच गया. और पार्टिकल 1 जो है ये डाउन आएगा, 5 मिलीसेकंड में डाउन और 5 में अप. तो इसका मतलब है ये यहीं पे रहेगा. तो अब आप जो वे, और इसी तरह जो पार्टिकल नंबर 5 है, पार्टिकल नंबर 5 नीचे आएगा 5 मिलीसेकंड में, फिर 5 में ऊपर, तो ये भी यहीं पे रहेगा. तो इसका मतलब ये हुआ बेटा कि आपकी ये वेव इस तरह बन गई. लेकिन चूंकि इसमें हाफ ऑसिलेशन हुई है तो ये हाफ वेव आगे भी ट्रेवल करे. अगर हाफ ऑसिलेशन है, हाफ टाइम पीरियड है, तो हाफ वेव आगे जाएगी. क्वार्टर टाइम पीरियड है तो क्वार्टर वेव आगे जाएगी. और अगर वो आपको कह रहा है कि पूरे एक टाइम पीरियड के बाद, वेव के टाइम पीरियड के बाद वेव की क्या पोजीशन होगी, तो आपने एक वेव आगे और कंप्लीट जो है वो बना देनी है. ओके, अब इसमें I would like all of you to try this question, and in this question what you have to do is, let me tell you about it. The wave is having a time period of 10 millisecond, 10 millisecond, ठीक है. आपने बताना ये है कि ये, और ये t टाइम पे ये वेव बनी हुई है, तो t + 2.5 मिलीसेकंड पर वेव की न्यू पोजीशन क्या होगी ये आपने बताना, ठीक है. तो ये डायग्राम जल्दी से अपनी कॉपी में बनाएं और इसको फिर रीड्रॉ करें जल्दी से.